Hi there. Continuing the topics around infrastructure segmentation. Now let's take a look at VRF Lite. VRF Lite is kind of a VPN that allows to build different routing tables or kind of virtual routing tables on the same device. And for instance, let's say that we have router 39 and router 37. They're directly connected to router 5. Uh, the beginning, in the first instance, they will be in the same routing table. That's what's called the default routing table. And we might have a kind of requirement of even an exam that states that we should prevent these two routers from reaching each other and without using any filtering, any ACL, route map, or anything like that. And we should also allow the advertising of the network sitting behind these two routers to, let's say, R3 and R1 without adding additional links on the path. But don't add any additional links, don't use any filtering technology, just use what you have. So VRF Lite can be used to meet this requirement, and this is actually what we're going to do. So let's start by configuring R39. Let me just confirm here which addressing do I have. I have 1007, so I have to change this to match the new one, and I'm going to make these N5 39 39 55 55 55, and I'll just create another OSPF instance. So IPSPF area 0, and let's create a loopback interface and advertise this loopback. Okay, and we're going to do the same for 37. So 37, going to create the network 10 5 37 37, going to be 24 IPSPF 37 area 0. Going to create a loopback as well, and 37 37 37 32 and IPOSPF 37 area 0. So this is done. So now on router 5, if we look at my interface of 3, I have to configure everything from scratch. So we're going to start by creating the VPN for this customer, and we're going to use on this side of the network kind of 39, where 39 router 39 ASA 15 and router 3 will be placed, is going to call VPN customer A. And for router 37 ASA 16 and router 1, we're going to place inside the VPN customer B. So it's going to look like this. I'll say customer A, and I have to assign a route distinction to make this unique. And we're going to use this identification is going to be 15 and 39, meaning that's ASA and ASA 15 and the route 39. And at the interface level, E03, we have to assign this interface into this VPN. So it's going to be IP VRF forwarding customer A. Gotta enable the interface, and it's gotta be 10 5 39 5 5 5 5 0, and the OSPF running is 39. And I gotta do the same for customer B. Route distinction is going to be 16 37, and the interface is 02, and IPVRF forwarding customer B, and IP is going to be 10 5 37 5 5 5 5 5. IP OSPF 37 area 0. Okay, so I have a JCC, just show neighbor. I have two neighbors, 37 and 39, so that's okay. Yes, 37 and 39, that's okay. So now at the link facing R4, we have to carry this VPN, and the requirement stated that we are not allowed to add additional links, and to do that, or what we can do is to use a router on stick. So meaning this link between R5 and switch, we have to make a trunk link, and we have to use sub interfaces on R5 and place those sub interfaces inside the customer's VPN. So if we look at E0, I'm just going to clear that, and it should be E0, and let me just use create the two sub interfaces, and this is going to be, I'll start with 39, and I'll use encapsulation 39 and place this inside the customer, forwarding customer A, and the IP between R5 and R4 is going to be 10.455/24, and I'm going to add the routing process SPF on this one, and 37 IP VRF forwarding customer B, IP address 10.455. IP is on, oh yeah, encapsulation.1q 37. Yes, and IP OSPF 37 area 0. And one of the great advantage of VRF Lite is that we can use overlapping addresses. For instance, you can see, just show run E0 39 and 37. I'm using the same address space, and that's okay because they're sitting in different routing tables, like the virtual routing tables. Okay, so now on the switch I have to make these two links that are facing the routers as trunk links, and I should have VLANs for these, and I have 37 39. Okay, and what I'm going to do is make these two interfaces 00 and 01, switch port trunk encapsulation.1q, switch port mod trunk, and I'm just going to allow all the VLANs to be sent across these two links. So now on R4 we have basically to do the same thing as we did on router 5. So starting by creating the VRF. So customer A, route distinction is going to be 1539, and I have to create I believe that's 0039, and let's see, probably I have to clear the interface. Yes, so 39, and I have to enable tagging 39 and VRF forwarding for customer A. The IP is going to be 10.454, and it's going to be a /24. IP OSPF is going to be 39 area 0. So now let me create VRF B, and the route distinction, and we can see the adjacency has already been established. So for customer B, route distinction is going to be 1637, and I have to create the sub interface for this one. It's going to be 37 encapsulation.1q 37, and it's going to be inside VRF customer B, and the IP can be the same, network 10454/24, and OSPF is going to be 37 area 0. So failed to okay, I got it. Assign a unique router ID. So I'm going to do this for 39. My router ID is going to be 44439, and for OSPF 37, router ID is going to be 44437. Do clear IP OSPF process. Yeah, I'm sure. And I should see adjacency with R5 on both links, and the way the other, so the election process is taking place. Okay, so the link between R5 and R4 is done. So now I have to do the same thing between the link with ASA 15 and ASA 16. So E1, let me see what I have configured. Okay, let me clear that. E1, so it's going to be E139 and encapsulation.1q 39, IP VRF forwarding customer A, IP address 10, say 10.4.15.4/24, IP OSPF 39 area 0. And do the same for customer B. No, make it 37, encapsulation.37, IP VRF for customer B, and address is going to be 10.4.16.4/24, and IP OSPF 37 area 0. Now this switch has to enable that link as a trunk link, and then I'm going to assign the VLAN, specific VLAN to each ASA. I should have the VLANs already here, 37 and 39. So the link facing router 4 is going to be a trunk link, switchboard trunk, encapsulation, mod trunk, and this is going to be an access port, and it's going to be on VLAN 39. As for E2, switchboard host, switchboard access, VLAN 37. Oh wait, yes. And let me just remove that VLAN 378. Just show VLAN brief. Yeah, that's what I want. And it's done. Now on ASA, this is going to be just a regular configuration. Let me bring ASA 15. Okay, and so let's see what I don't need to do. So 01, so 10.4.15. Okay, that's great. So let me see routing process 10.4.15, and that's okay. So SPF neighbor, it's up, show router SPF. So route OSPF, and I should see 3939 here. Okay, so now what I have to enable is OSPF adjacency between ASA 15 and router 3. So probably I have to change the interface. Oh, yes, the outside interface. So it's going to be 10.3.15, 15, 255, and the router process, I believe I'm using router process 1. Double check, yes, it's 1. Going to be 10, 3, 15, 15. Can be slice 32, area 0. And I'm going to bring R3. Do I have 10, 3, 15? Okay, it's already there. So probably this is a layer 2 configuration missing. So switch 17 has to place I'm going to create different layer 2 domains, one for ASA 15 and 3, another one for ASA 16 and RAR1. So I'll use the VLAN 15 interface range for E0 and E2 switch port host, switch port access VLAN 15, and let's see, 01 and 03 switch port host, switch port access VLAN 15. So layer 2 is done. So now let me bring ASA 16. ASA 16, what do you have? So I have to configure everything from scratch. Okay. So my G01, that's my inside interface. Name if inside. IP address going to be 10.4.16.16.45.45. No shut. And 00 is going to be my outside. IP address is going to be 10.1.16.16. This is between R1 and ASA 16. It's going to be 24. No shut. For RAR SPF. I already have this. Run RAR SPF. Yes, I do. So all I need to add is 10.1.16.16 for my area 0. Okay, so is R1 ready? 10.1.16. Yes, it is. Let's see what it has configured. And show IPO SPF brief, and I have my loopback. Type around SPF, and I should see, okay, 77 loopback address. It's already being advertised, and I don't see 39 here. And the same should be true for R3 routing table. I should see 39, but I don't see 37. And you can test reachability from 39. If I get to 37 and 39. So routing table of R1 should be here, which means that be able to ping starting from my loopback. I can. And the same should work for 39. You see RC in my routing table, and start from my loopback. It's working. So that's it, guys. VRF Lite configuration with RAR on stick as well. So I hope you guys enjoyed, and I'll see you on the next one.